Hello everyone. So today's contest was really good. It went really good. Digit range. The first one is of digit range. Let me know how many have you solved this problem. The first problem, right? Sum of integers with maximum digit range. This is the first problem. I think we aren't live yet. Yes. Okay. So the first problem, one question, bro. It's okay, bro. The second one was intuitive. I thought of solving it with just two pointers, but it needs storing, storing those. And how many you solved? I solved the first and second problem. So the second problem needs storing the prefix and also suffix, right? We need to have the prefix and also suffix, and we need to get. I'll tell you when we go there, right? Let us solve the first problem. Meanwhile, the time we go to the second problem, there will be much people starting to attend this lesson, right? Sum of integers with maximum digit range. You are given an integer array nums. The digit range of an integer is defined as the difference between its largest digit and smallest digit. For example, the digit range of 5724 is 7 minus 2, which is 5. Return the sum of all integers in nums whose digit range is equal to the maximum digit range among all integers in the array. Let us take an example 5724 triple one 350. 5724. Jai, hi bro. Hi, how are you doing? Is it your first time attending this live session? Let me know how many have you solved that problem. It is quite intuitive. I also thought of binary search, but it doesn't work. Let us think about the first problem. Question 1. Nums is equal to 51. What was that? 5724. 5724 111. Sorry. 111 350. What is the difference for this? Digit range. Digit range is maximum number. What is the maximum digit? 7. What is the minimum digit? 2. 7 minus 2, which is 5. What is the maximum and minimum digits? 1. So 1 minus 1, 0. What is the maximum and minimum digit? 5 and 0. So some of those which are having 5 as the digit range. Maximum digit range is 5, so I'm just adding 5724 plus 350 would give 476074. That all TC done, bro? No. I haven't even submitted a thing, even submitted a code. I thought of bind search, but it isn't working. Right? Let me know your approach. Now, what is our intuition here? Let me tell you, I need to let me tell you what if I just calculate the maximum range first. Calculate the maximum digit range first. Digit range first. Then iterate array, iterate array and add the elements to answer which are having let me write it like that. Add the elements with with max digit range. Add the elements with max digit range to answer. So if I write code for this, and let me know if you are stuck somewhere. Calculate the max digit range first. Iterate array and add the elements. So how do I calculate the max digit range? Let me take max is equal to int minimum. I would call for digit range function. So for int x in nums max maxi. will be maximum of maxi, comma, digit range, D range. I'm talking like D range of X. Nothing but I'll get the maximum. I'm just updating the maximum. Now, if I write D range, I'm just converting int N, right? So I'm converting it to string, but the better option is taking maximum and minimum. Let me use another color instead of this. I think it's much visible now. Yes. So int here max is equal to int min and mini is equal to int max, while int x is equal to n mod 10. Maximum will be max of maxi comma x, and minimum element or minimum digit will be minimum of mini comma x, and would say n by is equal to 10. We would just return max minus mini, return maxi minus mini. Now I got the maximum digit range here, right? It was like checking for all subarray. Then for each element in subarray, get all prime factors of each element in subarray and store the prime factor in map with value being product of element prime factor belong. Okay. You're saying that we need to get uh, checking for checking all subarrays, right? Then for each element in subarray, get all prime factors of each element. Okay, prime factors of each element. Then store the prime factor in map with value being product of element prime factor and prime factor. Let us go to the third problem in few minutes. Not saying it's just my intuition. Okay. That's a good intuition, bro. Storing the prime factors. But let's complete the first problem first. Right, so maximum is updated, however, for int x in nums again. If d range of x is equal to maxi, then answer. I'm very bad at explaining. Okay, it's okay, bro. It's okay. Answer is equal to answer plus x. That's it, right? So let me change the code. The code which I used is having this maxi like this. So while n int x is equal to n mod 10 and maxi is equal to maximum of maxi comma x. Now you have explained it very well, brother Jay. Right? N by is equal to 10. I'm also using this mod. As you know, it might go with runtime error. So I hope it's good for you all that you have understood the first problem. And if you haven't understood the first problem, please let me know. I'll be back in a few minutes. So yes, we'll be going to the second problem, right? Subsequence after one replacement. I hope I'm audible. Subsequence. Here, subsequence after one replacement. We are given two strings S and T. S and T. Consisting of lowercase integer. You may choose at most one index in S and it will set value at that index with any word. Let me tell you this easily. Let me question two. So we are going with let me say A, B, Q, A, and D is A, N, B, C, and N, D, O. If you see, if you see one thing, let A and A they both are matching. B and B they both are matching, right? Now here D and D they both are matching, E and E they both are matching. If I just change this C to C Q to C or N, then I can make this as a subsequence. You know the subsequence, right? Otherwise return false. I hope you understood this, right? Just change, change only one character. That's what we are allowed to do. Change one character and make S as T. S as a subsequence of T, right? I hope you understood it. Let me tell you how I solve this. Let me tell you why two pointer doesn't work here. Imagine, just imagine. Um, I have WQ and I have XWK. If I just use two pointers here, if I just use two pointers here, then I have W here, then I have X here. They both are not same. What I think is change W to X. Then I have a Q, then it is not possible, right? So W and X are not same. But what if I store instead of this, I go to here and store the W and W are, you know, have met. Like storing. Let me tell you my approach. Which so storing for S of I, storing where does S of I falls in T. Something like I have a W here, I have a W here. I would store something like left of 0 as 1. Why? Because if I go from left of in this string S, then I can make left of 0 is equal to 1. I can make till here, till this index, I can get that subsequence in T. Let me tell you. Left of I says that we have a subsequence in T which is equal to S of 0 to I. Right? Did you understand it? Let me tell you this again. Let me tell you the left array for this S will be something like 0 and 0, they both met at 0, right? And I have B, where at 2, I have B. Now, do I have a Q? No. So for all of that, I cannot make Q, I cannot make D, I cannot make A. First, I cannot make Q. So it would be minus 1, minus 1, minus 1. Nothing but, as I cannot make Q, all the other will be minus 1. Nothing but left of I makes us clear that I can make the subsequence till this index 1. Nothing but I can make this subsequence. I can make this subsequence. Now, let us uh, let us think about right. Can I make E? Where can I make E? I can make E at which index? Let me write it. 0, 1, 2, 3, 4, 5, 6, 7. I can make E at the index of 7. At D, I can make it at 5. Now, Q. Can I make Q here? No. So it would be minus 1, and then minus 1. Right? Let me tell you one thing. Let me tell you one thing. Now it becomes simple for me. It becomes simple for me that I have subsequence which matches. Right? If I take this as L, if I take this as R, and L plus 1 is less than R. L is 2, 2 plus 1, 3 is less than 5. Why I am saying 3 is less than 5, then only I am saying that L plus 1 is less than R, then return true. Let me tell you why I am doing this. Right, I have left, I have right, I have L as the index where I get the last uh, subsequence, right? L as the index where I get the subsequence of the left part. R as the subsequence of the right part. Now, in between these two, if I have in between these two, in between these two, let me use another color like green. In between these two, if I have some indices 3, 4, if I have in between these two, 3 and 4, I have these, which means I can change this index, this character to some of the character in between these two, right? It means if I have I, both of them are minus 1. If I have L plus 1 is less than R, then I would return true there itself. That's what I wrote here. Let me write the algorithm. Let me write the algorithm first. The algorithm looks simple. Left of size n with minus 1. Right is also of size n with minus 1, where n is the size of S and M is the size of T, right? I'm just initializing left and right. Now, let us go from index to index. For I is equal to 0, I is less than n, I plus plus. Now j is equal to 0, while j is less than m and s of I is not equal to t of j, then j will be incremented. Now, if j is equal to m, that means, let me tell you what does that means. I am saying at q, a, b, q, d, let me take that again. S is equal to a, b, q, d, e. T is equal to a, m, b, c, n, d, o, e. Now, I have found for a and b here, but q. I have started my search after this. After this B. I have searched after this B, but I went out of bounds. Nothing but J is equal to M, right? Then break. Why? Because let me tell you, I am searching for Q after this B, where I got B, I got here, I got here, B, I got here, and then my J shifted to the uh, next index. Now Q and C not equal Q and N, D, O, E not equal to Q. So J is equal to M. That means all these cannot be made equal or cannot be searched as a subsequence in T, right? In the string T, I cannot make from this Q. Why? Why? Because left of I stores the index I till where I can get subsequence in T. Now, left of 1 means till here. Left of 1 is having something means till here I can generate as I have a subsequence in T, right? So I hope you clear about that, right? Left of I means we have a subsequence from 0 to I in T, right? So keep that in mind. Now, if J is equal to M, that means we need to break. That means there is nothing we can do. If not, left of I will be j, and I also have to increment my j, so j plus plus. First, j will be assigned to left and j will be incremented. Do the same thing again. J is equal to 0, excuse me. J is equal to 0 for I is equal to n minus 1, I is greater than or equal to 0, I minus minus. While the j is greater than or equal to 0 and s of I is not equal to t of j, then j minus minus. Now, if j is less than 0, then break. That means we went out of bounds and right of I will be j minus minus. That's it. Now, after this, when I have weights, if 1 minute, 1 minute, imagine, imagine I have created left with having some of these like imagine instead of q here I have n. So so A B N D E A B N D E A M B C N D O E S and then D. So left will be something like let me give 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, 5, 6, 7. Let me match these A, B, and D, E. Left. Now I have A and A, 0 and 0, right? A is at index 0 of t, B is at index of 2, N is at index of 4, D is at index of 5, E is at index of 7. What does this mean? Last character also matched with some subsequence. Last character is also matched with some subsequence. Then we don't need any changes. We don't need any changes. That means if left of n minus 1 is not equal to minus 1, then return true. That means till the last character I have matched with some subsequence in T, right? So, so if left of n minus 1, if left of n minus 1 is not equal to minus 1, then return true. Do the same, do the same with right. If right of 0 is not equal to minus 1, return true. Now, I have something to do with this. I have right j is equal to m minus 1, sorry, it should be m minus 1 as I'm going from right to left. While j is greater than or equal to 0, s of I is not equal to j minus minus, j is less than 0. Okay, now L will be minus 1 if I is greater than 0, if left of I minus 1 is equal to minus 1, continue. That means I cannot make something like the previous one haven't been assigned, then I'll just move forward. L will be left off I minus 1. Nothing but, nothing but if I am at index like this, here, if I'm at this index, then the previous one will be L. This will be my L. That's what I wrote. L is equal to left of I minus 1. R is equal to M if I plus 1 is less than N. I plus 1 is less than N. And right of I plus 1 is equal to minus 1. That means when I'm here, if it is the next one isn't being assigned or isn't matched with S, then I'll just continue. R will be right of I plus 1 if the next one is assigned, right? So, so at this point, I have only one thing that I can change. Only at one index I have a mismatch. I have a mismatch. 2 and 5. Only one index have a mismatch. By changing only this character, I can I can change it, right? So only condition is if L plus 1 is less than R. If L plus 1, 2 plus 1, 3 is less than R, which is 5. 3 is less than 5, then we'll return true. If not, we'll return false. That's what I wrote it here. And if you have any doubts till here, please let me know. Right? I hope it's clear. This is quite intuitive problem. Anush bro, I think you're still in live. Please let me know. Jai W. Anuj. Okay, wait a second, wait a second. Am I audible now? Right now. Am I audible? Hi Hemant bro. Hi. How are you? Stephen Jones. I was not able to solve subsequent problem. Tried greedy by picking and replacing the first appearance of my side, but did not pass all test cases. Okay. Okay. What now? What about is it fine? Is my audible? Am I audible to you? I think I have to refresh it. Now what do you think? But I don't understand the second problem. Right? Did you understand the second problem? Let me know your name. Subsequence after one repair. Okay. Now my voice is gone. What about now? I have connected this. Also enable the audio. Can you please check now? So, can you please check now, bro? So let me know. Is it still? Is the voice still stuck? Let me check the voice. Right. So let me know. Right now, is it audible? So if you have any doubts, please let me know. Right. So if you have any doubts on first and second problem, and I got 5 bucks, so penalty time for 5 times. 5 minutes for each round. Let me check the ranking here. It would be 20,000 somewhere, 5,000. That's good. Yes, I'm going to discuss the third problem. 1 second. Divisible game. Okay. What I thought was it would be easily solved with binary search. Let me tell you. Let me tell you what I thought. Alice does one thing. We are given with array nums of length n. Alice and Bob are playing a game. Alice chooses an integer k such that k is greater than 1. Two integers L and R such that 0 is less than or equal to something like he chooses a subarray L to R and K which is less greater than 1. Initially both Alice and Bob's scores are 0. Alice's score is 0. Bob's score is also 0. Now, if nums of I is divisible by k, Alice's score increases by nums of I. Otherwise, Bob's score increases by nums of I. The score difference is Alice's score minus Bob's score. Okay. Alice wants to maximize the score difference if there are multiple values of k. To achieve the maximum score difference, she chooses the smallest such k. Then the product of the maximum score difference and the chosen value of k, since the result can be large, alternate modulo 1 in 9 plus 7. One thing is I need to choose some sub-array, right? Which gives me maximum difference. So if I need maximum difference, allies have to choose those elements which are divisible by k, right? So there are many things here. What I thought is having a DP, right? And the constants are much more. Also thought that having a grid or 2D DP would not be a great idea. Okay, let us think k is equal to 2, L is equal to 1, 2, 3. All values in are divisible by 2. So Li's score is 4 plus 6 plus 8. Let me go with someone. Jai have said some approach, right? Jai. Okay. You told an approach. So let me go by that. Every element, I would store. Nums of I can go till 1 is 6, right? So what if I store all the prime factors or whatever? I can get prime factors. Store prime factors for every element. Now, from this, from this, I can have many prime factors. For 1 e6, I can have 1 e6. How many prime factors will be there for 1 e6? Let me tell you one thing. Um, what uh, if allies choose some k as a prime factor, right? Let me write by taking 1468. 1468. Here I would store for 1, I have only 1 as the prime factor. For 4, I have 1, comma 2, comma 4. And for 6, I have 1, 2, 3, 6. 1e4, but we don't need all of them because we will only check for factor for current element. Yes. So here 1, 2, 4, 8. Now, what if k is equal to 1? 1 by 1 is 1, 4 by 1. If it is divisible by k, then allies would get 4 for allies, plus 1, plus 4, plus 6, plus 8. Sorry, k cannot be 1. Sorry. That's why I got a mistake. K is equal to 2, right? So 2. Is 1 divisible by 2? No. Is 1 divisible by 2? No. 2. So it would be minus 1. 4 divisible by 2? Yes. Does 4 have a prime factor? 2. Yes. So 4 divisible by 2? Yes. So plus 4. 6 divisible by 2? Yes. Plus 6. 8 divisible by 2? Yes. Plus 8. So from this, if I had the cadence algorithm here, if I implement the cadence algorithm here, then I would get easily 18. Now 18 into 2, which is nothing but 36. Let us take k is equal to, what are all those I would consider for k? Those which I have the prime factors. The prime factors, I only select the prime factors. So k will be 3. Now, is 1 divisible by 3? No. Is 4 divisible by 3? No. Minus 4. Is 6 divisible by 3? Yes. 6 by 3 plus 6 minus 8. From all these, if I write the cadence algorithm, if I implement the cadence algorithm, if I implement the cadence algorithm, then I would get 6 as max. 6 as max. So 6 into 3, 6 3 is 18. Now let me have this uh, here, and let us go k is equal to 4. K is equal to 4. Then is 1 divisible by 4? No, minus 1. 4 divisible by 4? Yes, yes. So plus 4. Is 6 divisible by 4? No. Is 8 divisible by 4? Yes. But if I take this 12 minus 6, if I take the current solver, 12 minus 6 will be 6. If I just take these two, it would be minus 2. If I just take 4, it would be 4. If I take 8, it would be 8. So the maximum will be 8 here. So 8 into 4 is 32. If I take k is equal to 6 and I have k is equal to 8. So let us implement them. K is equal to 6, k is equal to 8. Is 1 divisible by 6? No, minus 1. Is 6 divisible by 4 divisible by 6? No, minus 4. Is 6 divisible by 6? Yes, plus 6. Is 8 divisible by 6? No, minus 8. Here, plus 6 is the only option I have. So, I have 6 as the maximum from the current algorithm. So, 6 into 6 will be 36. Even then, I didn't exceed this 36. Then let us go with 8 again. 1 not divisible by 8, so minus 1. 4 divisible by 8, no, minus 4. 6 divisible by 8, no, minus 6. 8 divisible by 8, yes. Here, plus 8, so 8, okay. 8 is 64, right? If I just take 8, so did it tell that if nums of I is less score increases by nums of I, otherwise Bob's score increases by nums of I. The score difference is I's score minus Bob's score. If I just take this, I can have 8 which is 64. There is some confusion. The score difference is 8, which is maximum possible. Maximum possible. The score difference is Alice wants to maximize the score difference. Okay. He wants to maximize the score difference. He doesn't want to maximize the product. Sorry, she, Alice is a lady. So she wants to maximize the score difference. This score difference. What is the maximum score difference I can get? That's all. That's it, right? What is the maximum score difference that I can get? That's all the problem is about. So for 1e6, as Jai said, 1e4 would be the maximum. Even for 1e4, even for 1e4, 1e4 into 1000 would be 1e7. I'm thinking like, I'm thinking like storing a priority queue, something like that. Priority queue, which stores pair int comma int. Nothing but this maximum score. Karan's algorithm will return the maximum difference, right? The maximum difference every time, Karan's algorithm. So, max difference int, this int is nothing but k. So, what I would do is for int x in nums, I would get factors of x, get factors of x, push into, I would create a set of int available or valid factors. So push into insert into valid factors. Now what I would do, iterate through valid factors, right? Valid factors. I'm just iterating as I iterated like k is equal to 2, 3, 4, 6, 8. If if saying it as valid factors as k, if k is equal to 1, just don't look at that thing as k is 1 is not, you know, let me tell you, bro. What I'm thinking is they asked score difference. They asked for maximum score difference, right? So I'm choosing what are all the available 2, 3, 4, 6, 8 case. Why I'm selecting only these? Why? Because Alliance wants to add the elements to his score, so there will be maximum score or maximum score difference. So if I want to add a number to maximum score difference, then I would check from all these numbers what are those factors. I have 1, 2, 4, 1, 2, 3, 4, 6, and then 8. I'm just checking if I take 2. Then I would get plus 4, plus 6, plus 8. I would create an array, right? I would create an array and implement the cadence algorithm, right? Plus 4, plus 6, plus 8 would give me 18. Now, now I would push 18 comma 2 into priority queue so that it would have priority queue. It would have the maximum score on top. They asked the score difference, right? Alice wants to maximize the score difference. If there are multiple values of k that achieves the maximum score difference, she chooses the smallest such k. So she chooses a k, right, which is having the same score difference, right? So I am using a priority queue, right? Let us use priority queue with, or let us use something like unordered map. Let us use unordered map. Let me tell you why. Instead of priority queue, I will store unordered map, where I will store the maximum score and vector of int. Nothing but all those k values, which are having the same maximum difference. If you see, 8 is having 8 is having a repeated again with 4 as k, 8 as k. I need the maximum score difference, right? Did you understand SN creations means should? Did you understand, Shub? And if you don't understand, please let me know. I'm taking all the factors of all these elements, right? That's the first thing I'm doing. Factors of all these elements, and I am choosing what is the maximum score difference I can get. Here I got 18, here I got 6, here I got 8, here I got 6, here I got 8. Why? Why? Because I'm choosing a sub array which is having the maximum score difference. What algorithm did I use here? I would use cadence algorithm. Cadence algorithm to get 6. Right? So is it clear? I think it's clear for you. If you have any doubts, please let me know. Right? If k is equal to 1, continue. Then, if not, I would create a vector of int temporary array and push for int x in nums if x mod k is equal to 0, then temp dot pushback nums of x temp dot pushback x. Else, if it is not divisible, else temp dot pushback minus x. Now, let the maximum difference is the current difference is int current difference is apply the cadence algorithm and on the temporary array which we have created, and the maximum difference will be maximum difference comma current difference, and we will have, instead of vector of int, we will have set of int in the unordered map. So MP of current difference dot insert k. I hope it's clear. I'm just iterating, and in the unordered map, I have the current difference. I think it takes much lot of time. Right here, let's throw valid factors as k. If k is equal to 1, continue vector of int temp. So if x mod k is equal to 0, temp dot push by x. Now, I would choose the maximum difference of the first element. Return max difference into MP of max difference dot begin. Right? Okay. So mass difference. Something like the first thing we need to get the factors of x, and also we need to get cadence algorithm. Let us get the factors. Get factors int n. So I think I can just, instead of having another get factors function, instead of having get another factors function, let me have something like this. For I is equal to 2, I is less than or equal to n, I plus plus or x, I plus plus. If the x is divisible by I, then valid factors dot pushback I, right? Let row valid factors as k. Let us think about the cadence algorithm. Maximum subarray. Subarray lead code. Here we use the current algorithm. I hope I have solved it already. Yes. Let me paste the cadence algorithm here. Right. I have the maximum sub array. Now I'll write the same thing. Set of int. Let me name it as st, and then I'll convert it into valid factors array. Right. For int x in num, get factors of x as like this. For int I is equal to I is less than or equal to x, I plus plus if x mod I is equal to 0. Then st dot insert I, right? Then after this for loop, iterate through valid factors. So vector of int valid factors with st dot begin comma st dot end. Right, I have the valid factors now. Now for int k is equal to, okay, let me take it as I is equal to 0, I is less than. Let us take int k in valid factors. Here, if k is equal to 1, continue. There will be no one, however, as we are skipping I is equal to 1, so let us not go with that. Vector of int temp for int x in nums. If x mod k is equal to 0, then temp dot pushback x, else temp dot pushback minus x. Then int current difference is equal to currents or maximum subarray of temp. Then int max difference is equal to maximum of max difference comma current difference. We should not have a maximum difference like this. Int max difference is equal to int min. Right. That's it. MP, I haven't initialized the unordered map int comma vector, sorry, set of int as MP. Now MP of current difference is dot insert, okay, right. Then after this return max difference into MP of max difference dot begin. Let me run that first. Why be an error? Maximum summary of temp. Error. Undeclared identifier max. Or did you mean max sub array? Okay. How do we get the first element? So int first element or k first element as mp of max. Let me take a set. Is this output is 0? The expected is this. I must choose some k, the smallest possible choice is k is equal to 2. Because Ramsa's 0 is not disabled by 2, our score is 0. While Bob's score is 1. The score difference is minus 1, which is the maximum probability. Therefore, the answer is minus 1 into 2 is equal to minus 2. So they are iterating k from not only for valid factors, they are iterating from 2 to 1 is 6, right? Mod 1, okay. Let us define int mod is equal to. Okay, there is something here. Let's let's try for any hint. Look for any hint. What people are discussing here. This is easier than say, oh God. Give me a second, what's that? I want the upside and this one. This is more of a math problem. First thing is the constant there allow n square solution. Next is picking which numbers are possible, and the brute force is the factors of each number can be candidate. So try all fact. For this, all the factors of each number can be candidate. So try all the factors of each number. So put them in a set, and then to check we can use cadence as check. Simply boils down to number which are divisible by k should be taken as positive and other negative. So we have positives and negatives, and we are asked maximum continuous average. So is equal to cadence. So okay, problem is contest level. There's something here couldn't break down. Let us just do like this. If n is equal to 1. nums of 0 is equal to 1, then just return this. But it won't work for many test cases, right? It doesn't work if all the elements are 1 or something like that. No. Long first element is equal to into 1 LL. Let me take this test case. Got answer. Okay, if the cadence algorithm returns only 1, if the difference is if I'm not having any difference, right? So if mp dot empty, then run a cadence algorithm for int the maximum difference will be run a cadence algorithm max up array of nums, then return k is equal to 2 maximum difference. Wait a second. Is it divisible? Is not divisible. My score is 0. While Bob's score is 1. The score difference is minus 1, which is a maximum of minus 1 into 2 is minus 2. Return this. However, every time you get it, return this. If all those are ones, then return this. Nothing much. Nothing much, just return. Okay. It should work, right? Should definitely work. No, time limit exceeded once. God, there is something this TLE. Let us take a set and convert it into nums too. Nums set. So set of int nums set of nums dot begin nums dot end and vector of int nums2 as numset dot begin numset dot end. Let us take this. Why? Because the same thing is repeating again, so might not get time limit extended. Yes, god damn it. It is not optimized, but we have solved it. I'm thinking in the same way, right? That's that's great. That's great. And we have just implemented the cadence algorithm. God, I thought we couldn't solve it. The third problem. We successfully completed the third problem. In one day, we have solved three problems. When I started at 8 and now it's 11, it means just 3 hours. The most of the time was taken for the third problem, right? Let me write what I did here. Store factors of distinct elements in a set. What do we name it? Valid factors, right? So, store factors of distinct elements. How do I get the distinct elements? Right? Let us change it. Let us change our variable names. Store factors of distinct elements. Let me name uh, nums set of int nums set as nums dot begin and nums dot end. Distinct elements as vector of distinct elements nums set dot begin nums set dot end. Store factors of distinct elements in a set valid factors. Yes. Let us create a set um, of factors first. So for every distinct element, for int element in this distinct elements, I'm just writing the code in a good way so that everyone understands. Um, for int I is equal to 2, I is less than or is equal to element I plus plus. If element mod I is equal to 0, then factors, I'm just taking the factors, dot insert I, right? I'm getting all those distinct elements. Now I need to change the factors to valid factors. A vector of int valid factors as factors dot begin factors dot end, right? I'm having the valid factors which I can use. Now I will have the unordered map which will having the difference and the k values in a vector. So I would use unordered. Let us use a great name, int comma vector of int. Let me name it as difference with k values. So difference with k values, nothing but go to every factor as k for int k in valid factors. Take the cadence algorithm here. Take the cadence algorithm here. First thing, create a temporary array, vector of int temporary array. I'll go to every element in nums. In nums, go to every element in nums, not in this nums set, right? Right. So for int x in nums, if x is divisible by k, x mod k is equal to 0, that means it is divisible, then temp dot push back x. If not, else temp dot push back minus x. Minus x. Right, I have this temp. I need the current difference. How do I get the current difference? Int current difference is maximum sub array of the temporary array. Right, now I have the current difference. Let me change the maximum difference as maximum of maximum difference comma current difference. Okay, I have the maximum difference now. Now this difference with k values will have difference. Instead of vector of int, I'll have as a set of int. Set of int, right? So difference with k values of this difference, the current difference, dot insert the current k. Now that's the last step, right? That's the last step, yes. Now, now, what if I just remove this? Uh, just remove this. If mp.empty, that means the only element in the whole array is just one. If mp.empty, that means we need to return this thing. One, how many times I got zero here? 2, 3, 4, 5, 6, 7, 8, 8, 5. 1, 2, 3, 4, 5, 6, 7, 8, 5. If mp is empty, then let me take a set of int set with max difference or case k values with max difference will be um, difference with k values of maximum difference. Difference with k value of max difference. Now, the first element, long, first minimum k value. Let us take it as minimum k value. Minimum k value as k values with max difference dot begin into one long so that it would be changed to long, then long mod value is equal to 1 in 9 plus 7, then just return max difference. We need to initialize max difference into minimum k value mod. Here we will have max difference is equal to int min. Max difference is equal to int min. So let us start changing the variable names. Okay. Int skill nums int set of int nums set nums dot begin. Distinct elements. It is not like this. Distinct elements. Where is nums of 2? At that place, I would change it to distinct elements. Nums set dot begin x store set of int factors. Instead of this factors. Now instead of here factors. Mod I is equal to 0, I is less than element in distinct elements. I is less than or equal to element mod I is equal to factors dot insert I. Vector of int valid factors dot begin. Of int difference with k values. Difference with k values. For int k valid factors. Vector of int temp, int x in nums, x mod k is equal to 0, temp dot pushback, int current difference from maximum over of temp, max difference from maximum of max difference. Difference with instead of mp, oh god damn. Again. See here I have used this difference with k value. Then again I am having mp. Difference with k value. Write as difference with k value. Right, set of int k values with maximum difference. K values with max difference. Difference with k value. Minimum k value. Long minimum k value. It's equal to k values with maximum difference. Dot begin. Long max difference is equal to minimum k value. Let me see. Yes. I'm thinking to post this solution in solutions tab. Right. So everyone who have attended this live session, thank you very much. I think that's a good problem, bro. That's a good problem. How much time did we take here? How much time is it? 1 hour, not 1 hour. 1 hour, 32 minutes. When an integer are nums, your task is to find the maximum subarray of nums, that is a palindrome. The maximum sum of such a subarray. Okay, the subarray needs to be palindrome. I need to have all those subarrays which I have. That's an interesting problem. Num slot length is still 1 if I think I can check each subarray. If it is palindrome, I would consider the sum. Let us try the brute force first. Brute force first. Store question 4. Now question 4. Um, get the maximum sum of a subarray where the subarray where the subarray is a palindrome. Is a palindrome. Now I would take the prefix sum, however. Let us write the prefix sum first. For I is equal to 1, I is less than n, I plus plus. Pre-sum of 0 is equal to nums of 0. Now pre-sum of I is equal to pre-sum of I minus 1 plus nums of I. Right? I have this prefix sum. Now I would go for I is equal to 0, I is less than n, I plus plus. For j is equal to I, j is less than n, j plus plus. If is palindrome of nums comma I and then j, then get this sum. Let's take n plus 1. Let's take prefix sum of 0 as 0 itself. 0 as 0. 1, 2, 8, 2, 3, 4. Then at 0 I would have 0, 1, 2 plus 1, 3. 8 plus 3, 11, 11 plus 2, 13, 13 plus 3, 16 plus 4, 20. So which is of size n plus 1. Pre-sum of I is equal to, for I is equal to 1 till n, pre-sum of I is equal to pre-sum of I minus 1 plus nums of I. So I should be less than or equal to n. Yes, less than or equal to n. For I is equal to less than or equal to n. Pre-sum of I is equal to pre-sum of I minus 1. Yes, pre-sum of I minus 1 plus nums of I. Nums of I minus 1. Yes, I minus 1 here also it is I minus 1. So here it would be I minus 1. So prism will be of size n plus 1. Vector of int prism of n plus 1 comma 0, and then I don't need this top. I is equal to 1. I is less than n, j is equal to I is palindrome. Then what would I do? Answer is equal to maximum of answer comma pre-sum of j minus pre-sum of I minus 1. J plus 1, I think so. If I have j here and I here, then for till 3 I will be having at 16, right? So pre-sum of j plus 1 minus pre-sum of I will be at 13, right? 8 plus no, not at 13. 8 plus 2 plus 1, 11. The sum of I plus 1. No. The sum of I. 16 minus 3 will be 13. So if I consider 8 to 3. So prism of I, prism of j plus 1 minus prism of I. J plus 1 minus prism of I. J plus 1 minus prism of I. Return answer. Answer is equal to int n. And how do I calculate the valid function? Let me change this to some other color. Is palindrome. Nums left, right. For L, L is less than L plus R by 2 and L plus plus. If nums of L is not equal to nums of R, then return false. What if 1, 2, 3, 4, 5. 1, 2, 3, 4. L is here, R is here. L plus R 6 by 2, 3 is less than 3. Yes, it should be less than 3. L is here, R is here. L plus R 1 plus 4, 5 by 2. 2 2's 4. So, this palindrome should check like if L plus R, R minus L plus 1, R minus L plus 1 mod 2. And like if it is odd, then I would go limit is equal to 1 plus 5 6 by 2 3 less than 3 L plus R by 2. Then limit will be equal to L plus R by 2. Else, if it is odd, 1 plus 4, 5 by 2, 2 plus 1, right? Limit is equal to L plus R by 2, however, limit is equal to L plus R by 2. If it is odd, if it is odd is equal to 0, then only limit plus plus. Hope you understood this. Here we are using limit such that it doesn't go out of that. So for L, L is less than limit and L plus plus, here R minus minus if nums of L is not equal to nums of R, then return false. If not, return true at the end. Long answer is equal to int main. Let's take a long bin. Let us take long for everything. I didn't see this long n plus 1 comma 0 2. Be sum of I minus 1 plus nums of I minus 1, right? For int I is equal to 0, I is less than n, I plus plus. For int j is equal to ij is less than n, j plus plus. Here if is palindrome, if is palindrome nums comma I comma j, answer is equal to maximum of concept comma pre-sum of j minus pre-sum of I, return answer. Here is palindrome, is palindrome vector of int nums, int n, int r. Here if r minus l plus 1 is equal to 1, return true. Int limit is equal to l plus r by 2. If r minus l plus 1 mod 2 is equal to 0, then a limit will be incremented. Nothing but it is just a way of saying for L, L is less than limit L plus plus. If nums of L is not is equal to nums of R, then return false, and then make it R minus minus, return true. I hope it would work for the small test cases. Let me run it. But it won't work for the biggest palindromes, as it is 1 in 9, right? I know 1 in 9. Nums of I is 1 in 9. But time it takes it. Let's see here. See here how much big are these test cases. Just look at this test case. Just look at these test cases. Use prefixums to compute to try expanding around each center to find the longest span group. That's a great idea. Don't forget to check both the odd and even length parameters. That's a great idea. That's a great idea. Yes, we can also check the palindromes like this, right? Odd length palindrome and also even length palindrome. How do I get the odd length palindrome? I is equal to 0, I is less than n, I plus plus. If I have 3 here and I have a 1, I have a 1, I have a 5, I have a 5. Now I am at this I. So let R is equal to I plus 1, L is equal to I minus 1. So nums of L is equal to nums of R. I would increase the R plus plus. If nums of L is equal to nums of R, then I just decrement L minus minus and R will be incremented, right? So for L is greater than or equal to 0 and R is less than N, sorry, Y, else will break there itself. Then if you see what is the maximum we'll get, this is how I get the, this is how I get the, what do you say, the maximum palindrome length. This is how I get for the odd length, odd palindrome, odd palindrome. This is the odd palindrome. What about the even palindrome? You know, I have breaked at some point. If L is less than 0 and R is equal to N, then the whole palindrome, then the whole array is a palindrome. Return, then accumulate nums, sorry, 0 comma 0 comma nums dot begin. Nothing but I am just taking the whole nums array, nums dot end. Else what I would do is L plus plus R minus minus. Now
answer. Answer will be maximum of answer comma I have from L to R. What did I say here? L to R. If I have from L to R, then pre-sum of R plus 1 minus pre-sum of L. Pre-sum of R plus 1 minus pre-sum of L. R plus 1 minus pre-sum of L. Do the same thing. Do the same thing with even palindrome. Even palindrome. How do I get the even palindrome here? Let me take L is equal to I, R is equal to I plus 1, while L is greater than or equal to 0 and R is less than N. If nums of L is not equal to nums of R, then break there itself. Else, what do? We'll just decrement L and we'll just increment R. Now have L and R. If L is less than 0 and R is equal to N, then return the same thing. Return accumulate 0 comma nums dot begin comma nums dot end, right? Else what do? Answer is equal to maximum of answer comma pre-sum of j plus 1 or r plus 1 pre-sum of L. What do we do here previously? L L plus plus R minus L plus plus R minus same thing. L plus plus R minus. That's it. That's a huge code, but let us see. Even odd palindrome and even palindrome, right? Odd palindrome and even palindrome. Int L is equal to I minus 1, R is equal to I plus 1. Odd palindrome here. While L is greater than or equal to 0, R is less than N. If nums of L is equal to nums of R, then L minus R plus else break there itself. Here, if L is less than 0 and R is equal to N, return We don't need all this. There is a clearly excuse me. Accumulate or there might be some error here. Zero LL should be not here. Instead here. That's it. That's how you do. Let me check whether it runs for all the test cases. God damn it. Again, time limit exceeded error. I think we cannot do with this. Don't forget to check both the order and length. I'm checking both the odd and even length palindromes, but still it is giving me. Sorry. If I have here pre-sum of n, let us run uh, pre-sum of n instead of accumulate. Let us take the time limit exceeded error. Let us use the test case. No, it seems the time limit exceeded here. Where can we optimize it? Let us do previous size. Let us take long. Right now, if pre-sum of r plus 1 minus pre-sum of l is less than previous, then break itself. Let us look at the solutions, how these people are solving it. Manage, what is this? I'll solve this definitely and post it in LeetCode. Right. So that's it for today. If you have any doubts, please let me know. It's already 2 hours, 2 minutes, right? Thank you, everyone.